and it includes a lot of mathematics. And I thought at least we shall organize for one physical class, so at least we can represent the semester that we did a class together. So there is this section which deals with clutches and the brakes, the design of clutch and the brakes. That section I have skipped so that before the semester ends, that is maybe probably when we shall opt to do uh, a card, of which we can do an open book card. We can as well do that section. So for today, let's discuss jigs and fixtures as it pertains to the production of especially parts and equipment. We need to understand what is jigs and what is fixtures, what are the differences between the two, and the working principles for the two parts. Starting with a jig is a device in which a component is held and located for a specific operation in such a way that it will guide one or more cutting tools to the same zone of machining. So remember, in production, whether is mass production or workpiece or a batch or a few elements production in our workshop, we normally consider what we call efficiency, accuracy, a cost issue, and also time issue. For us to consider all those factors, we need jigs and fixtures to enable us achieve that one. So for instance, in a simple workshop like a university setup, we have different machining operations. For instance, you can do drilling, that's one of the machine operation or machining operation. You can do milling, you can do drilling and boring, you can do facing, you can do turning, name all of them. So you need to secure your workpiece on a given machine so that you can be able to do an effective machining. For instance, if you want to do drilling or boring, you need a jig. A jig, which is a device which will guide your cutting tool. The cutting tool in this case is the drill bit or the boring tool to a specific mark where you would like to drill that hole. So this jig is basically a bushing, a cylindrical bushing that is placed or placed on a specific point or location to guide a drill bit, or whether it's a reaming or a boring tool. We have two types of drill jigs. We have a drill jig and we have a boring jig. All of them serve the same purpose to guide or direct a cutting tool to a specific point or location for the purpose of accuracy. Apart from accuracy, it can also help us to uh, reduce or minimize time of machine operation. So a simple jig is as displayed here. We have you can see here we have a drill. This is a drill bit. Around it we have a pushing. A pushing is like a cylindrical element. Then we have a workpiece beneath it. You can see a dotted line, like a rectangular section. That is a workpiece. Then the workpiece has got locating pins or supporting pins. So the other part is just the frame. So in our normal workshop, we normally uh, um, clamp our workpiece using, for example, a vise. You locate a workpiece accurately using a vise. That is after you have marked your workpiece where you want to drill your holes. Then you bring down or you turn down the levers so that you can bring down the drill bit to that marked point so that you can start the drilling. But sometimes you cannot be able to locate exactly that marked point because the drill bit can easily bend when you are rotating. It can easily bend and break. To avoid such scenarios, we use drill bit. Drill bit is essential in mass production when repeatability is crucial. Repeatability, it means that you are doing the same job over and over again. We have types of jig bushes. We have press fit bushes for short runs, renewable bushes for high wear applications. So in this renewable, it means that you can be able to change or you can be able to fill the worn out bushes. It's like the sleeve cylinders for the engine. They normally wear out and you can replace them. The same case to this one. While you are doing the repeated jobs of inserting the drill bit and removing it, the bushes get worn out and you will need to replace them. We have slip bushes for multiple operations, threaded or spring loaded bushes. This is for the purpose of drilling internal threads. We have special bushes with end shaped. Then we have plate bushes combining two or more bushes. We have design principles for pushing. What principles or what consideration do we need to consider when we design drill pushing? So first we need to ensure that the drill bushing or the jig, that is the jig, facilitate ease entry of drills or withdrawal. Ease entry or withdrawal of drills. Then there should be no sharp corners on the body of the push. That's why on this diagram you can see something like a curved butt or a top or a cover. That is to avoid a sharp ending. So basically it's not like a real cylinder, but you can have something like a cover. Loose or screwed in solid bushes should not be used where accuracy is essentially important. So in this case, you need a removable bushing or bushes. Let's go to fixtures. A fixture is a production tool that locates, holds, and supports the work securely in a fixed orientation with respect to the tool so that the required machining operation can be performed. So the key words here are locating, holding, and supporting. While for the jigs, it was to hold, it was to guide, it was to basically guide. So we have a symbol diagram here for a jig, any for a fixture, whereby we have the table. This table can be related to the milling table, a drilling machine table, a CNC table. So you can be able to relate this one to those tables of different machines. We have the workpiece here, and then we have the cutter. This can be a milling cutter. So on the table, you can see the keyways. The keyways which enables to insert these T slots. We have keyways which has got the T slots. So these T slots, you can be able to insert, for example, T bolts. So these two T bolts are like locating pins or supporting pins for the workpiece. So in this case, the T bolts that's which are inserted from the bottom act like a supporting and locating pins. We have also a barrier. You can see here a fixed barrier here, and it has got a locating pin so that the workpiece is secured. It can't move downwards, nor can it move forward, assuming this cutter is moving from right to the left. So it means that the workpiece is secured or fixed. So this part which is fixed here, you can see like L. This one is just a design consideration of which you can sign something. Uh, you can sign a block. You can design a block which is in form of L, L-shaped, but it has got slots also to enable us to have this kind of pin which you can see here, which are an horizontal pin. Main components of jigs and fixtures or the elements, they include rigid body, locating elements, clamping elements, guiding elements, positioning elements, and indexing elements. Let's start with rigid body. This one implies a workpiece. A rigid body in this case is a workpiece. Locating elements, they locate and position the workpiece accurately with respect to the tool guiding or setting elements in a fixture. So in this case, if you consider this diagram here, you can see the pins. Those pins I have been discussing are the one which are considered in this case as locating elements to ensure the workpiece is at the correct position. Clamping elements, in this case, you can have, for instance, a vise. A vise normally has a screw and a lever so that you can turn. But in this case, the clamping element can be also the T-bolts. By tightening it, you are clamping the workpiece. Considering this workpiece cannot move upwards since we have the cutter on top. So when you tighten the T-bolts from the bottom, you are as well clamping this workpiece. Tool guiding elements, that is just jigs. Positioning elements, they are the pins we have discussed here, just to ensure that the workpiece is at the correct position. Indexing elements are normally meant for when cutting gears. It's just a plate which has been indexed. It has been marked out of 360 degrees. You can mark, for example, 30 degrees, 20 degrees, 60 degrees, 80 degrees, and so forth, so that you can be able to do accurate cutting of gears. Or sometimes you can do drilling. You can make holes around a circular plate, and for you to do that one or to achieve accurate portion of such holes around a workpiece, you need an indexing element which normally turns together with the workpiece. While you turn the indexing element, the workpiece also rotates or changes the position. So we have a diagram here which represents those elements. For instance, we have a drill here. You can see the drill bit. Of course, the drill bit is connected to the spindle of the drilling machine. Then you can see the jig bush here. We have a bush here. We have the frame around it. We have a frame around it. We have a workpiece at the middle. You can see a workpiece which is rectangular. Now we have a clamping screw. A clamping screw which, by turning, probably if you turn clockwise, it extends. While it extends, it presses on this workpiece. That is clamping. By doing anti-clockwise rotation, that's unclamping. So we have also adjustable locating pin to ensure that the workpiece does not translate in the horizontal direction. So it is secured or located using this adjustable locating pin. So basically, this is a jig combined with a fixture, because we said the main function of a fixture is to support, to clamp. So you can see the support here and clamping. We have support from the bottom supporting pins. We have 1, 2, 3. Also, this adjustable pin is also another supporting element. So that is a basic jigs and fixture combined. We have the differences between the two here. I will just mention maybe probably two, then the rest you will go and check them. A jig controls and guides the machining tool, while a fixture holds and supports the component precisely for machining operations. Jigs ensure accuracy repeatability, and interchangeability, while the fixture provides a reduction in error by holding a component firmly on the table. So on your own time, you go and check the other differences. Advantages of the jigs and the fixtures. One, productivity. So in this case, productivity improves. For instance, if you are assigned in your workplace to produce, for example, we can say gears, or you are producing a shaft which has got several holes. So by fixing your workpiece on a machine table, whether it's a drilling machine or a CNC machine, and by guiding the tool accurately, you will be able to improve the number of products you produce by a given day or per week, depending on the definition of the productivity. Interchangeability, jigs and fixtures facilitate uniform quality in manufacturing of components. So in this case, you can be able to produce different products or elements using same tools and fixtures. But if you need to change a design, of course, you need to change the design of the jigs and fixtures. Skills reduction. So in this case, the expertise required for one to produce a given component is minimized. So remember, in traditional production, experts were required to do a simple job. But nowadays, with improved technology, we just need a machine operator. Just simple instructions, then you let the machine to perform the machine operations, compared to probably somebody who is using an analog lathe machine. That individual needs a lot of skills. But in this case, skills are not really required. Cost reduction. Remember, cost issue is related to time used to produce a component. Also, a factor like the number of employees you have to produce a given quantity. But remember, when you are using jigs and fixtures, you reduce the labor costs. So with reduced labor costs, automatically the cost of production goes down. Design considerations in fixtures. The main frame of fixture must be strong enough to avoid deflection. Frames may be built from simple sections so that they can be fastened with screws or welded whenever necessary. Clamping should be fast enough amount of effort. Either you can use screws. You can use we have pneumatic hydraulic clamping. There are so many. Clamps should be arranged. So we have so many. Let's start regarding to the location and clamping of a workpiece on a machine table. We need to consider those principles separately. We need to consider the location principle and also the clamping principle, which we have said we have different types of clamping. But let's start with the principle of locating. So basically, we need to understand the axis, the normal axis. We normally have X, Y, and Z axis. From those axes, you can generate different planes, X, Y plane. You can have Y, Z plane. So from this diagram, you can see this workpiece, which is defined by different axes. We have X axis, we have Y axis, and Z axis in the vertical direction. All right. So any rigid body has got what we call degree of freedom of movement, or of degree of freedom of movement. So normally a body has got 6 degrees of movement. So if you don't secure this workpiece, it can move along the Y, that is 1 degree of movement, along the X, along the Z, and also you can rotate this workpiece on around all the axes. You can rotate the workpiece along the Y axis, along the Z axis, or around, and also around the Z axis. So we can count the degree of movements. There are six. Y, that is 1, along the movement of this body along the Y, that's 1, along the X, that is 2, along Z, that is 3. Now rotation around Y, 4, rotation around X, 5, rotation around Z, that is 6. So you can't do a machine operation on this workpiece unless you secure at least 3 degrees of this. So let's check this diagram on a jigs and fixture. So different views, top views. So we have, which is indicated diagram here where you can see my cursor. We have this inner rectangle. You can see the inner rectangle. That is the workpiece. That is the top view. This is the top view. And this one is the, I think, side view. So for us to locate or to limit the degree of freedom of this workpiece, you have to introduce, or you have to confine the workpiece accurately using the locating elements, which in this case is F, D, and E. D and E prevents this workpiece from moving towards the right side. So at least you have secured or you have located that part. But of most important, it's secured, or it is constrained to move towards the right or towards the left because of this frame. You can see this frame. We have a frame here. So D and E are locating bins which are confined to this frame. So the workpiece is confined. It will not move towards the left. So what about from the side? How will we fix the movement along the X? We have also this frame here, which has got the locating pin F, right? So also from the bottom, it has been fixed, or it is located by pins A, C, B. We have those pins which have been placed there to locate the workpiece. Then we have side F. We have F at this point. You can see F is similar to this other side. So simply we have constrained this workpiece to at least two, we can say if we had 6 degrees of freedom from this analysis or from this diagram, I do believe we have arrested all, because you can't rotate this workpiece since it is rectangular and it has been confined from all sides. So you have constricted all kinds of rotation. It can't rotate, whether it is along X, along Y, or along the Z. Similarly, it cannot translate, it cannot move along X, along Y, and along the Z axis. So the explanation which is given here, you will go and follow up, but the most important thing is constraining the movement of the workpiece. So we have when you locate a workpiece which has got a flat surface, we call it location from plane surface, of which we have discussed up there. Let's just elaborate more on that. We have a flat or a rectangular workpiece here. Then we have the locating pins, which you can see here, 1, 2, 3. So this one prevents the workpiece from moving downwards. If it is locating the workpiece to prevent it moving sideways, you can see also these 2 locating pins here, 1, 2, A and F. So this workpiece, you can be able to see it has the 5 locating pins. From the bottom, not really 5, but you can have more depending on the side location. But if you check this one, we have from the bottom side, we have 5. 1, 2, 3, 4, 5. That is to prevent the workpiece from moving downwards. Then from sidewise, you can have 2. So this one can only be applicable when you are dealing with what we call milling. Milling, and you are doing a facing operation. So while, for example, the milling cutter is moving towards the left, so this workpiece can neither move towards the left, because we have this barrier here. We have this barrier AF here, so it cannot move towards the right. And because the milling cutter has got a downward applied force, these pins, the lower pins, will support it, will support the workpiece. So we don't have locating pins from the right, because the cutting tool is moving from the right to the left. So there's no need of having the support from the right since the force is directed towards the left. So what about when you have a profile workpiece? For instance, if you want to mill a curved section, in form of a semicircle, you can place your locating pins. You can see locating pins around or along the curved section, so that if, for instance, you have to, in this case, and they are the one which are necessary, so you can see here we have point 1 and point 2, and probably the cutter is moving from the right to the left. So this workpiece is basically secured. It cannot move. What about if you are locating or you want to secure a cylindrical section or a shaft? So in this case, you need to confine the shaft so that it cannot move it cannot move in a transverse manner. You can see here we have a conical shaped section here, same case to this other side. So these are basically the dead and live centers. This one are basically found in lathe machines. So we have left this cylindrical element to just rotate because probably we are doing the turning. Only we are fixing the workpiece not to move transversely, or that is along the x-axis, but we have allowed it to rotate. Also, you can use what we call a V-shaped blocks. There's something what we call V blocks. You can place your shaft on V blocks, then you can do your machining on that workpiece. It depends of operation you want to do. Probably you want to cut using a punch saw, so you need to fix on a V-shaped blocks. So those are some of the ways you can locate and secure your workpiece. That is when you have a cylindrical workpiece, when you have a formed shape or a profile shaped, and when you have a regular shape, that is a rectangular or square shaped. So for clamping, we have discussed about location. For clamping, we have design consideration for clamping. The clamping system should be strong enough to withstand forces developed during the operation. Clamping should be positioned to direct the clamping force on a strong supported part. The clamping system should not obstruct the path of loading and unloading of the workpiece. Clamping time should be minimized by using hand knobs, Tommy's bars, nailed screws, and so forth. Clamping system should reduce operator fatigue. The clamping point should not be provided with arm radius to make the clamp operable even if there's variation in workpiece. So we normally have different clamping systems. The main one are listed here. Pneumatic clamping. This one uses what we call compressed air. Mostly in lathe machines. Lathe machines normally comes with a compressor. Of course, the compressor is to produce compressed air, and that compressed air is the means of power transfer, so that it can open some valves for the purpose of clamping and unclamping. So the main purpose of pneumatic or compressor in CNC is for clamping purposes. Hydraulic system, this one uses hydraulic fluids. This one is normally used where a lot of power or force is required compared to pneumatic clamping. We have also vacuum clamping. Vacuum clamping is normally used when, especially when you want to hold, a merely flat sheet of, iron sheet, for example. This one mostly is used in automotive for the purpose of holding and transferring sections which are flat, and this one is basically iron, we can say sheets, generally sheets. Also nowadays we have magnetic, it's not indicated here. We can also have magnetic clamping. Especially I noted one machine, a grinding machine, whereby you can hold a workpiece on the table by just activating the solenoid which is attached to that table. So the table is converted into a magnet. But that one is a temporary, not a permanent magnet. It's just by switching on and off. By switching on, it means that you have given it power, that you have given it electrical power so that it can be magnetic. Steps of fixture design. You have to plan what you want to do. For example, what machine operations do you want to perform? Whether it's drilling, facing, mill cutting. Gather the information regarding the machines available. That is whether they have table attachment like devices. Develop several options and choose the best one. So in this case, as an engineer, you need to think on the possible kind or possible jig and the fixture which can be used to produce your workpiece or your product. Implement the design using, you already have standard components that it can be rectangular, it can have a form profile. Use predefined materials and keep tolerance as liberal as possible. So later we shall have some design of jigs and fixtures, but we shall follow this procedure which is indicated here. But of most important, it is required of you as an engineer to be creative. The there's no standard design for jigs and fixtures. It is you to design yours depending on what you want to produce. So this content is purely open. It's purely open, so there's no specific design for such equipments or jigs and fixtures. Essential features for milling fixtures. If we focus on milling fixtures, we need to ensure the fixture is strong enough so that it can be able to withstand heavy forces and the severe vibrations from the milling machine. It must have thrust. Heavy thrust caused in milling should be transmitted to a strong solid structures or frames. Cutter settings. Suitable cutter settings. Cutter setting pieces should be provided for easy and accurate tool setting. Machine locations. You need to locate the workpieces. Of course, we have talked about T-bolts. And in this case, we have what called the tenons. It must be rigid, though rigid goes hand in hand with strength. That's a similar thing. And also motion. We need to have what we call minimized motion of workpieces or the motion of the cutting tool. Remember, either the cutting tool can move or the workpiece can move because the table itself is supposed to change location or is supposed to move by either rotating or by just translating from one position to another. So to avoid that one, you need to secure firmly your workpiece to minimize the motion of workpieces and also to improve what we call the accuracy. So we have an example of a hinged clamp. This is a type of clamp which can be used in a milling cutter. So I will like to elaborate what is happening here so that later you will follow up. So from the word hinge, it means that it has a cover which can rotate on a fulcrum that is hinged. It has a hinge, that's a fulcrum. So we have the table here which supports the workpiece. Now we have these other sections or frames, but all of them are not fixed. So in this case, we don't have a fixed frame as compared to the simple example we have discussed up there. So in this case, you can see the stop here. This means that this section can have some degree of rotation, probably 30 degrees, until it is stopped by this fixed stopper. The same case, the top part, which of course is a rectangular, is also rotating around this point. So meaning it's like a lid. You can open and close this section together with the support of this hinge. You can see this hinge here. So simply this fixture, it can be opened and place your workpiece. After placing your workpiece, you just make this hinge to be vertical and then close this upper section by tightening this. You can see something like a nut here, so you can join the upper and this hinged eye bolt. Then you can also tighten the workpiece using this nut. You can see here, you can see a nut here. By closing, you are tightening this workpiece, which is enclosed at this point. So this diagram and this one, they are the same. It is only that it is the side views. So you can see after closing what is happening here. So you have your workpiece at the middle of this box, of course, which has got pins from the bottom to make sure it has been well located. Then the top part has been used to tighten the workpiece. The same time, whatever you see here as the nut, it can be used as the jig for the purpose of drilling. So also you can modify from your side. You can think what you can do with this design so that you can come up with your own design. For instance, you can see we don't have the lower pins, the lower locating pins. You can be able to introduce and remove this supporting what we call bifolded clamping block. You can remove this bifolded clamping block and replace it with the locating pins. So this was a hinged clamp. What about if we have something related to swinging leaf jig? Swinging. So swing is to turn. So you can see a frame, fixed frame. Now in this case we have L-shaped fixed frame. Compared to this one, we didn't have any fixed frame. All of them were hinged. But in this case, we have a fixed frame. Then we have another frame here. You can see my cursor. Then we have the top plate. The top plate has got a clamp which has a diamond shaped for purpose of turning and turning. So this is like a screwdriver or a screw. By turning clockwise, you are tightening the component here, the workpiece. By doing the reverse, you are untightening. You can see bushes. We have two bushes here and here. So also we have this knob here. This knob is meant to tighten the upper plate. So what is done here, you have fixed your workpiece. Yes, already you had marked, for example, a position where you want to drill, and exactly you placed your jigs. So the next thing is to place your drill bits. It's just to direct the drill bits to these holes, and by doing that you will drill an exact position, since already you had done what call positioning and clamping. So this is another symbol, jigs and fixture, which can help you to do accurate drilling. Remember, a jig. These two jigs here, the two bushes, are meant to guide to guide the drill bit to a specific position for the purpose of accuracy, while the screw is meant to position and clamp. What about leaf and large jigs? So we have a large, you can see this dotted part. It means that it is this top plate which has been turned. It has been turned, it's like 180 degrees. That's hello, sorry guys, I got lost, but we were almost completing. I just mentioned what was on this diagram, whereby I was talking about leaf or large jig. So in this case, I was talking about the top plate which has been turned or opened around this fulcrum. That's 180 degrees. By doing that one, you are leaving this space here to insert and remove this workpiece, which you can see here. This workpiece is located by the bottom pins. You can see them here. Now, by closing this top part, we have this screw here. We have this screw here. You can see the screw here. It's meant to tighten the workpiece, and also we have two bushes meant for drilling purposes. So by locating the workpiece and clamping it using this screw here, whether it's hand operated screw, then you will be able to guide your workpiece, no, your drill towards a specific point on this workpiece. So this one is just a modification. These are a modification of this type of drilling of jigs and fixture. You can see here, swinging leaf. You do the same drilling. We have to drill bush here. The same case is done here. The only thing which has changed is the design of this jig and fixture. So that's why I was mentioning, as an engineer, it is you to design your own jigs and fixtures depending on what you want to achieve. So for instance, the two same thing has been done. You want to do drilling of two holes, but jigs and fixture has changed. So this, and together with many others which you will encounter during your maybe your work or during your revision, you will notice that the main thing here to understand is what machine operation you want to do, and how can you be able to locate the specific point you want to machine and clamp it so that the workpiece does not move. Then direct the cutter or the tool to that specific point. That's the main thing for the jigs and fixtures, to secure the workpiece. Once to position the workpiece, secure the workpiece, then direct the tool or the cutting tool to the specific place you want to do the machine operation. If it is drilling, you need drill jigs or the bushes. If you want to do a cutting, that is milling cutter, that is facing, you will ensure the top part which you want to machine should be free of any attachment. So if you were to do machining on this upper section of this component here, you could not have clamped as this one. Probably you could clamp from the sideways, but not from the top where you want to perform the machine operation. So I think with that one we can stop there unless somebody has a question. Okay, if you okay, great, thank you. I will share with you these notes so that you can go and peruse through them. Then we meet next week as usual, but I think the other week we can organize the other week before, after next week, we can organize for a physical class so that we can do those two areas I've mentioned that requires some solving problems. Then we do an open book cut. So the class rep you can organize so that the other week we meet. Okay, thank you. Good evening.